Binomial theorem, Pascal's triangle.
Hello, lovely people. Today we'll be looking at binomial theorem under Wassce concept. Binomial theorem and the Wassce concept. Now, before we start this, we want to look at a certain man known as Pascal, and he brought something called the Pascal's triangle. The Pascal's triangle. So binomial theorem simple help us to expand some given variables. So it helps us to expand some given variables and get to the final answer. So for instance, if you have something like 3 plus 2x raised to the power 6. So now what will happen is that I have to, in the normal we have to be doing 3 plus 2x multiplying 3 plus 2x multiplying 3 plus 2x multiplying 3 plus 2x multiplying 3 plus 2x 1, 2, 3, 4, 5 multiplying 3 plus 2x. So I have to be doing this one by one. 3, 3, 9, 3 here, that will give me plus 6x. 2 this, that will give me plus 6x. 2 this, that will give me 4x squared plus. So after getting this, I can now multiply with this 4 left, 3 plus 2x. And I'll multiply this to it after I come in. So it's a long word. It's a really long word. So now, what happens is that binomial theorem, there are theorems like the combination theorem and other stuff that will help us simplify when we have something of this nature, how we can easily go about it. But before that, a man known as Pascal's triangle did a very interesting work by drawing a triangle of numbers. And this is what he did. He started from the top that if you have any two-digit number, exponent 0, any number exponent 0, or reach the power 0, it will give you 1. If I have numbers like a plus a, which is a constant, and x, which is a variable, reach to the power 1, then I'll be getting 1a and 1x. 1a and 1x. I'm drawing the triangle. If I have a plus x, that reach to the power 2, then I'll be getting 1a squared, and this will give you 2. So 1 plus 1 here, this is how you was drawing the triangle. So 1 plus 1 here will give you 2. So I get 2, and this a will reduce. So I get ax, 2ax. So now here's more or less like the x here is exponent 0, the a1, x1. And the last one here will become what? 1x squared. So now when I have a plus x, and I multiply another a plus x, what am I getting? I'm getting a squared, and I get a plus x, and I get another a plus x, and I get what? X squared. So to simplify it, I get a squared plus 2ax plus what? X squared. And that will be the triangle here. So we just add the operation signs here. So now here to simply means that the a is 0 because the a is decreasing, the x is increasing, and the x becomes squared. So this will go back to 1. You get x squared. This will go also back to 1. And this is what Pascal was actually doing. And now we have a plus x raised to the power 3. You get 1a, keep x naught. I get it. So you know that the x naught will obviously be to 0. And you come here. So this 1 plus 3, 1 plus 2. That gives you 2. So in the middle of that is 3. So the a is decreasing. The x is 9. So x was 0 here. Now x will become 1. Okay. This is also 2 plus 1 in the middle here, which is also 3. The a is still decreasing. So the a1, the x is increasing. The x becomes 2. And the last one, you put your 1 there. So it starts with 1. It always ends with 1, which becomes 1x cubed because the a will tend to 0. So you realize that anytime you draw the Pascal's triangle, when you begin the first letter, a cube, you have to end with what? An x cube. I get it. So this one, when you expand this, you'll be getting the same thing. For instance, a plus x, multiplying a plus x. So you realize that here, from the two of them, you get a squared plus 2ax plus x squared, multiplying a plus x. So when you do this, you are getting a cube plus, this one will give you a squared x, and it's done plus, this one will give you 2a squared x plus 2 2ax squared plus ax squared plus s cubed. So now realize that after that you are getting a cubed, and this 2 will give you plus 3a squared x. This 2 will give you plus 3ax squared plus s cubed. And that's the same thing you are getting here. Okay. Okay. Now, when you come to a plus x exponent 4, you are building. So you get here as what? 1a exponent 4, x naught. You take that out. 1 plus this will give you 4. 1 plus 3 will give you 4. So 4a cubed. The x is now started increasing. 3 plus 3 will give you 6. So 6a squared x squared. 3 plus 1 will give you 4. So 4a s cubed and the 1 x4. Okay, so you realize that the a is decreasing, the x is increasing. So let's do the last one. 1a x5. So you get 1a exponent 5 x naught. That's 5a exponent 4 x1. This will give you 10 a exponent 3 x2. This will give you also 10 a squared s cubed. And this will give you 5 a s exponent 4 and have 1 x exponent 5. And this is how the Pascal's triangle was built. This is how the Pascal's triangle was built. Let's take a typical example on how to use the Pascal's triangle. A typical example on how you use the Pascal's triangle. Now, let's take this particular question. That is, we should expand 3 plus 2x exponent 5. We are asked to expand 3 plus 2x exponent 5. So now when we come to the Pascal's triangle, ax exponent 5 is this one. This is the triangle. That means these are what we are getting. So if that is the case, a plus x, you compare. Exponent 5 was given as 1a exponent 5 plus 5a 4 exponent x1 plus 10a cubed x squared plus 10a squared x cubed plus 5. Okay, so plus 5e x exponent 4 and plus x exponent 5. 1x exponent 5. Okay, so now when you get this, what happens is that from this question 3 plus 2x exponent 5, from 3 plus 2x exponent 5, what happens is that we can separate it. So from here, a is 3 and b, the x value here is what? 2x. So the x value here is 2x and our 5 is 5. So now, wherever you see a here, we put 3 there. Wherever you see x over there, we put 2x. So now when you do that, you are getting 3 exponent 5 plus 5 into brackets a, which is 3 exponent 4, and x exponent 1, which is 2x exponent 1, plus 10 into brackets. So the a is 3, so which is 3 exponent 3, and the x, which is 2x exponent 2. Okay, so we continue plus another 10, which is 3 exponent 2, bracket 2x exponent 3, plus 5 into bracket, which is 3, bracket 2x exponent 5, sorry, exponent 4, plus 1x, and the x is 2, so 2x exponent 5. Okay, so now we have to simplify this further down, and when you do this further down, you are getting 3 exponent 5 will give you 243, plus 3 exponent 4 times 5 times 2x will give you 810x, plus 3 exponent 3 times 10 times 2x exponent 2. When you do that, you are getting 1080, that's 1080x squared. And when you do this to 3 exponent 3 squared, which is 990 times 2x exponent 3, when you do this, you are getting 720 x cubed. And plus 5 times 3, 15 to this. When you do this, you're also getting 240 x exponent 4 And the last one, you are getting 32, 2 exponent 5, x exponent 5. So 32x exponent 5. And this is how we are using the binomial, the Pascal's triangle to expand this particular equation. That's 3 plus 2x exponent 5. Now, we want to move straight forward into the binomial theorem. The binomial theorem. Okay. So let's move straight into the binomial theorem. Okay, so with the binomial theorem, what is the theorem? Okay, so with the theorem, anytime you have a plus x exponent n, so this is the theorem I'm giving. Anytime you have an equation of this nature in this same, where a is the first constant, x is the x variable, and the n is the number of times you are supposed to multiply itself, or it multiplies itself, then the binomial theorem says that first of all, the a will be exponent n plus n multiplying by the a, n minus 1, x exponent 1 divided by 1 factorial. So you just be reducing the number of n. Like for instance, when you had a plus x exponent 5, we realized I had a exponent 5, and we came to get 5a4. So we realized that the a was decreasing, so it's n minus 1. That's 5 minus 1. And we had our x1 all divided by 1 factorial. So that was the Pascal's triangle. But how do we build the formula out of it? And that is the binomial theorem. So as we increase, it comes back to n into bracket. The n also has to also decrease. So we get n minus 1 multiply a. And the a, now the n becomes n minus 1 into bracket minus 1 again. So it's in simple terms n minus 2 x squared all divided by 2 factorial. So the number of the degree of the x will be divided by its factorial. So the degree of the x will be divided by its factorial. So after this, plus n into bracket n minus 1, bracket n minus 2, a, n minus 3, x cubed, all divided by 2 factorial. All divided by, sorry, the cube is this, so it's divided by 3 factorial. So anytime you see, for instance, 3 factorial simply means 3 times 2 times 1. So if you have 5 factorial, it simply means 5 times 4 times 3 times 2 times 1. I guess if you have 79 factorial, it means 79 times 78 times 77 times 76 something. You get it? So up to that, the unit number 1. Okay. Now this will continue till we get to plus n into bracket n minus n, a n minus n, xn divided by the n factorial. Divided by the n factorial. Yeah. So this is the equation for the binomial theorem. For the binomial theorem. There's an example here. It says you should use the binomial theorem to expand this. Okay, so let's use the binomial theorem to expand 2 plus 3x exponent 5. 2 plus 3x exponent 5. So we want to use this theorem that we've been able to generate to expand 2 plus 3x exponent 5. So now what we can get here that 2 plus 3x exponent 5, comparing this to a plus x exponent n. When you compare, what do you get? You realize that when you compare these two, you are having a is equal to 2, and the x here is the same as the 3x, and n is equal to what? 5. Okay, so if this is the case, then you are going to use this equation. But you know we are going fifth term, so this is the first term, the second term, third term, fourth term, fifth term, sixth term, and so on. We are going the fifth term because of n is equal to what? 5. Okay, so this one, what do we do? It's very simple. So now we start, the first term is a exponent n. So we go straightforward, which is 2 exponent 5 plus, yes, n is what? 5 into bracket a is 2, n minus 1, which is 5 minus 1. So that gives me 4. And x is what? Was given as 3x exponent 1 or divided by 1 factorial. Okay. So now plus n, which is 5, n minus 1, which is 4, times a, which is 2. And the a is raised to the power n minus 2. That is 5 minus 2, which will give me 3. And x, the x is given here as well. 3x squared or divided by 2 factorial. Okay. So now you have the third term, it's left 2 more things. Okay, 1, 2, 3, okay. Plus 5, 4, 5 minus 2, which is 3, a, which is 2, plus 5 minus 3, which will give me 2, x exponent 3 factorial, and plus, so you move to, you get the x to be also what? Exponent 5. So that will be the full term. So we get to 5, also to n minus 1, which is 4, n minus 2, which is 3, n minus 3, which become 2, a, which become n minus 4. So when you continue, n minus 4, that will give you, so the a here is also 2, that is this, exponent n minus 4, that is 1, 3x exponent, the x is now increasing, sorry. So here will be 3x, sorry, because the x is 3x. So that will be 3x exponent 4 divided by 4 factorial. And the last one, the last expansion will become 5, 4, 3, 5 minus 3, 2, 5 minus 4, which will give you 1, times the a, which is 2 times exponent 0. So 2 exponent 0 is here. That's the same as 0. And 3x exponent 5 all divided by 5 factorial. Okay. So now, when you do this, and you calculate it, so you realize at this point, this one will give you 1. And the whole of 5 times 4 times 3 times 2 times 1 is it's more or less like also 5 factorial. So the whole of this will also take this away. So you get only 3x exponent 5. Okay, so when you do this, the top there you are getting 32 plus, when you do the whole of this calculation, you are getting 240x plus the third term, which is this one. After that one, you are getting 720 x squared 5432 exponent 23 exponent 3. When you do that, you are getting 1080 x cubed plus this term also 22, which you are getting 405 x exponent 4 plus our last term here, which is 3x exponent 5, which will give you 243 x exponent 5. Okay, and this becomes the final expansion. The final expansion. So the stress that you could have gone through to be multiplying this by itself 5 times, you can just use the binomial theorem to expand it to this. So otherwise you have been doing 2 plus 3x, multiplying 2 plus 3x, multiplying 2 plus 3x, multiplying 2 plus 3x, multiplying 2 plus 3x 5 times. But to go through this stress and do it systematically, you can simply use your binomial theorem to do it. Let's meet in another video as we go into the combination method in binomial theorem.